acid-base titrations. We are going to learn this lesson very slowly, step by step, through problems. Now let's discuss problems. 13.2 milliliter of a 2.5 m standard solution of barium hydroxide is required to titrate with 25.5 milliliter of a HCl solution. What is the molarity of the HCl solution? This is the chemical equation. HCl plus barium hydroxide, we get barium chloride plus H2O. This chemical equation is not balanced. First of all, we need to balance this chemical equation. Let's balance it. 2HCl plus barium hydroxide, we get barium chloride plus 2H2O. Now you can see on the left hand side 4 hydrogens, on the right hand side 4 hydrogens, on the left hand side 2 chlorines, on the right hand side 2 chlorines, and on the left hand side 1 barium, on the right hand side 1 barium, on the left hand side 2 oxygens, on the right hand side 2 oxygens. Now chemical equation is balanced. According to the balanced chemical equation, we can find the ratio. After that, we can find the answers slowly, step by step. (13.2 milliliter of a 2.5 m standard solution of barium hydroxide is required to titrate with 25.5 milliliter of HCl solution. 2.5 m. 2.5 m means molarity. That means there are 2.5 moles of barium hydroxide in 1 liter or 1000 milliliter of this barium hydroxide solution. In 1 liter or 1000 milliliter, there are 2.5 moles of barium hydroxide. But in 13.2 milliliters, there is less amount of barium hydroxide moles. In 13.2 milliliters, there is less amount of barium hydroxide moles. Now let's find it. We know the volume and the molarity of the barium hydroxide solution. Therefore, we can find the number of moles in barium hydroxide solution. Molarity of this barium hydroxide solution is 2.5. That means in 1000 milliliter of this barium hydroxide solution, there are 2.5 moles of barium hydroxide. Therefore, in 13.2 milliliter of this barium hydroxide solution, how many moles of barium hydroxide are there? We can find the answer in this way. 2.5 mole barium hydroxide divided by 1000 milliliter barium hydroxide multiplied by 13.2 milliliter barium hydroxide. 2.5 mole barium hydroxide divided by 1000 milliliter barium hydroxide multiplied by 13.2 milliliter barium hydroxide. We should cancel out units. Milliliter barium hydroxide, milliliter barium hydroxide. Now we get 0.033 moles of barium hydroxide. In 13.2 milliliter of this barium hydroxide solution, there are 0.033 moles of barium hydroxide. To find the number of moles, if we want, we can use formula of molarity, M equals N divided by V. Here we did not use this method. If we want, we can use In our molarity videos, we use this method, formula of molarity. If you want, you can watch those videos. This is the balanced chemical equation. I have written it here again. 2 HCl plus barium hydroxide, we get barium chloride plus 2H2O ratio. To react with 1 mole of barium hydroxide, 2 moles of HCl are required. To react with 1 mole of barium hydroxide, 2 moles of HCl are required. Now we have 0.033 moles of barium hydroxide. To react with 1 mole of barium hydroxide, 2 moles of HCl are required. Then to react with 0.033 moles of barium hydroxide, how many moles of HCl are required? We can find the answer in this way. 2 mole HCl divided by 1 mole barium hydroxide multiplied by 0.033 moles barium hydroxide. 2 mole HCl divided by 1 mole barium hydroxide multiplied by 0.033 mole barium hydroxide. We should cancel out units. Mole barium hydroxide, mole barium hydroxide. Now we get 0.066 moles HCl. This is not our main answer. Now we know the volume of this HCl solution. For this titration, we have used 25.5 milliliters. In 25.5 milliliter of this HCl solution, there are 0.066 moles of HCl. In 25.5 milliliters, there are 0.066 moles of HCl. Now we want to find in 1000 milliliter of this HCl solution, how many moles of HCl are there? It is molarity. Now we have to find the molarity of HCl solution. We can find the molarity, moles per liters or moles per 1000 milliliters. In 25.5 milliliter of this HCl solution, there are 0.066 moles of HCl. Therefore, in 1000 milliliter of this HCl solution, how many moles of HCl are there? It is molarity. We can find it in this way: 0.066 moles of HCl divided by 25.5 milliliter HCl multiplied by 1000 milliliter HCl. 0.066 mole HCl divided by 25.5 milliliter HCl multiplied by 1000 milliliter HCl. We should cancel out units. Milliliter HCl, milliliter HCl. Now we get our answer. We have found our answer, molarity. I use my calculator to find the answer. 2.5882 molarity. There are 4 decimal places here. 4 decimal places are not necessary. If we want, we can write it as molarity 2.59 m molarity. If you can understand this video, please subscribe our channel. Thank you very much for watching. God bless you.